Well, sorry for the delay between business trips and there's still snow on the ground from this latest storm and just work in general. It's been killing me and I haven't had a chance to catch up on the videos. And I really need to, of course, because the track's already been open a few times anyway, weather permitting. And I want to get this thing on the dyno and tested. So what we've got to do is we've got to drill a hole for our nozzle. Put that right in about the focal point. And it's going to go right in here. This is the top of the block. This is the blower side here, this giant opening. See if I can zoom out so you can see it. So you get the idea. It's a giant opening. I don't want to tilt the camera down and lose the shot. But this will go in and spray out that way. So we need to drill a hole in the top of the block. I've already laid it out, marked it, set the thing up in the mill. It's more or less centered on my mark with a center drill. It's going to be a little tricky because actually my mill does not go up high enough to change collets particularly easily. So I will have to do a little bit of fudge work here, but you know, let's see how it goes. What's the worst that can happen, right? So let me reach over and get my safety glasses here, turn this thing on, and start making holes. Okay. So one thing that's important to note is that this thing's going to have to be countersunk because the blower inlet side is huge. Even though the throttle body's also huge, it's not as huge as the blower side. So this is going to have to be countersunk a little bit, which is actually what I want because that's going to give me more clearance to the hood regardless. Plus I want to avoid this bolt. There's a screw here, which you can't probably see, but that's actually my throttle stop. So that hole goes in that way. So you know, basically, we'll just keep drilling out until we are ready to tap for this guy. Let me change tools. Alright, so I'm not going to lie to you guys, this took forever. This is actually a 6mm drill bit in a 1/4 inch collet. It's about 10 thousandths under, but because I don't have the right drill size for a 1/16 NPT, which this requires, we're going to start here. If I have to go out to a 1/4, which is actually what one of the nitrous companies recommends for these things, then we'll do that, but you can always go bigger. It's a lot harder going smaller. And to quote my teenager, that's what she said. Now, in case you're wondering why I'm kind of pecking into it like that, it's to keep the flutes from loading up with chips. It's basically something that you should do with aluminum. Oh, I think we're through. Yep, we are through. Alright, that was relatively painless. Let's take this bit out. By the way, that's as far up as the mill will go. One of the downsides of the mini mill. This brick, I think, is close to 8 inches wide. So, and I do have the air spring, which is supposed to be an extension, which is supposed to give you another inch or two of travel, which clearly we need here. So let's try and get this out. Okay. Just enough room. Well, let's take a look. Yeah. It's just barely big enough for that. I might end up going to a 1/4 inch. You know, I might just do that, because there's not a whole lot of play in here. 0.238, and the drill bit measured 0.235, so it did drill slightly over what it measured, but not by a whole lot. But for now, we'll just leave it there. It's easy enough to make the hole bigger should we need to. So the next aspect is going to be to countersink this thing. So we're going to take out the 1/4-inch collet. I don't know if the collets will actually come out. Oh, how about that? Just barely. And hey, I found it. Look at this thing. Isn't it a thing of beauty? This is a solid hunk of 5/8 carbide. I buy these things as regrind, so somebody reground it. But it's got a 90-degree point. And it is going to be an ideal countersink. Look at that thing. Just the weight of carbide. You know, as far as, not to be sexist or anything, but let's just be real. Most of my viewers are men. And from a men's point of view, the weight and feel of carbide is like a boy's best friend. Alright, let's go in here and make a hole and see how we end up. So we do know that this hole is pretty freaking deep. So, you know what? I'm going to zero out my pseudo DRL. And we're going to see how this thing does. I have never used this one yet. A little chattery. Yeah, it was an awful lot of work for 20 thousandths. Let's, the finish is spectacular. Contrary to what it sounds like. I mean, it looks really, really good. But I'm not loving the way this sounds and how grabby it is. Somebody maybe could put some suggestions in the comments. I mean, it could just be too much for this little mill. It's a possibility. I suppose I could also choke up on the cutter a little bit. That would probably help. You know what? Yeah, let's do that. Alright, that moved the whole fixture. I hit the emergency stop on that. Not liking that. And now we got a chattery bit of finish. Maybe, let's turn it back on so at least we can see. Maybe we need to just go with the end mills. This whole thing moved on me here. So let me refixture it up and try again. Alright guys, so here's the plan. My collets go up in 1/8 inch sizes, so I figured the hole is pretty close to 1/4 inch, 6 millimeters, 1/4 inch. Who's counting? And then, so next size up obviously is 3/8, so we'll go down 3/8. I only need to go down like 5/8 of an inch or so. So we'll do a 3/8, then a 1/2 inch, and then we'll try the chamfer mill again. Hopefully with more success. Let's give this a shot, see what happens. Let's zero out the pseudo DRO, and let's have at it. Okay, so here's the 1/2 inch end mill. Let's get it into position. Be right about there. Alright gents and ladies, we are back on the chamfer mill. So we've gone 6 millimeter, 3/8, 1/2, and now this 5/8 chamfer mill. We've gone down about 1/2 an inch. Let's see how this plays out for us. Hopefully this will work. And you know, just wish me well. I'm going to put some, actually this is tapping fluid, just to give it a fighting chance. And wish me luck, cross your fingers. Let's hope this goes better. Still wanting to pull itself in, but it's only got a clearance a 1/16 of an inch on the side. Ooh, I'm not like that. Sorry about that. Alright, let's back it out and take a look. Well, it looks decent. It's just wanting to chatter like crazy on me. Tighten my fixturing down a little bit. I'm sure that's part of the problem. If I had an angle plate or two here, it would be better, but I don't have an angle plate, so I'm going to make do with what we've got. But at least it's clean so far. I don't have a 5/8 regular end mill either, which is another issue. Do not like that at all. This is just asking for trouble. Let me come up with something else. Alright, let's try an actual chamfering tool. Remember, I've got to open this up anyway. This one's a bit on the big side, but let's see if this just works, because, you know, we're not having much luck elsewhere. Let's give it a shot. Alright, I like that even worse. Or I think that is even worse. Alright, well, let's go back to the tools and see what I can find. Alright, well, in the ongoing curse that this thing is turning out to be, I decided let's just go with 3/4 inch end mill. It's going to be cutting, I believe, 1/8 on a side because we're at a 1/2 inch in the primary hole. Now, the part that sucks is I have some killer solid carbide 3/4 inch regrinds, and they are sharp as all get out. This one is my next sharpest, and it's a high-speed steel hogging end mill, obviously. I don't know. Let's see if this works. We know we're going to need a pretty good amount of clearance for the nozzle anyway, so let's give this a shot. That's even worse. It's not good. Alright, try something else. Alright, you know we're getting desperate because I'm almost certain this isn't going to work. But, behold, a wood countersink. A dull one at that. Let's see what happens. Yeah. On one hand, it actually does appear to be doing something useful. On the other hand, this whole piece is moving. Yeah, not gonna happen. I got another countersink. I mean, it actually is working, but the amount it's moving the work around is kind of scaring me. But it actually is getting there. And because A, it's dull, and B, it doesn't have a positive rake, it's not trying to suck itself in. I have another one. Let's try the other one. Alright, let's not try the other one, because it doesn't fit in the collet. And there's not enough room for the chuck. Let me go back to thinking. Alright, this is very likely my very last ditch effort. This is all I got. I got no more. I had to move it off to the side to get it in, but I have a 1/2-inch boring bar. Now, it's not in the boring head, mind you. So, let's take a good look at that guy. Is it gonna work? Beats the hell out of me. But we've had no luck so far with anything else. So, what do you say we give it a shot? I had to move the thing over and then move it back and count the number of turns because I don't have DRO on that axis, and it's just a... Oh Lord. Cross your fingers. Say a prayer. Well, this looks like it might work. Alright, well, the boring bar worked, so now there is about as little for this chamfer bit to bite as possible. So it should definitely work here. But I'm realizing something else. But let's give this a shot. Let's at least drive this in just a little bit. See what happens. Now that it doesn't have that much to bite into, it's not trying to pull itself in. This is actually working out okay. Let's do a test fit. That could very likely end up working. It's not going to be as recessed as I'd like. Still, I'm going to try to get a little further in. Well, so here it is installed. This is from the blower. This is what the blower is going to see. Let's zoom into it here. See if we can focus on it. Yeah, somewhere in there. There you go. That's it installed. And now I'll take it out and you can look at the hole. That's what she said. So there is the finished hole. My God, that was a lot of work. But it's done. And this thing is ready to be put together. Finally. Thanks for watching. Subscribe. Bye.